22.
Okay, 20. Question number 22. Try to solve this first yourself and tell me your approach, what you will do. So first write down what things are given, right? So what are given? What is given in the question?
Mass
So let's write
of the
mass is
person.
equals to 65 kg, right? What else is given?
The mass of the snowball.
Okay. So this is the mass of the ocean, mass of the snowball, that is 0.045 kg. Okay. Forward with the ground, the speed of it. So the snowball is moving, right? So we will also draw a visual representation of what is happening, right? Is that right? That will help you better solve physics questions, right? So actually the snowball is thrown, right? Is that right?
Yes.
So a 65 kg person throws a 0.045 kg snowball forward with a ground speed of 30 meters per second, right? That means 30 meters per second, it is thrown like this. Is that right?
Yes.
A second person with a mass of 60 kg catches the snowball, right? Right?
Yes.
So there is a second person. So the first person is here who is throwing this snowball, okay? Oh, the snowball looks much bigger than the man, right? Okay. And the second person is here who is catching, who is trying to catch, right? Who is trying to catch that snowball, right? Both people are on skates, right? So they are on skates, right? Is that right?
Yes.
The first person is initially moving forward with a speed of 2.5 meters per second. Okay. So initially it was moving with a speed of 2.5 meters per second in the forward direction, right? What are the velocities of the two people after the snowball is exchanged? Okay, let's check that. So first consider the first man and the ball as the system. Okay, if you consider this as the system, okay, so when this person throws the snowball, okay, and when it was not throwing the snowball, was there any external force acting on it?
No.
No, right? There is external forces are acting that are gravity and normal, right? But there is no net external because they are cancelling each other. Is that right? So there is no net external. External forces are acting, but net external force is not there, right? That is zero. Is that right?
Yes.
Is that right? Okay. So net external force is zero on this system. So this system is isolated system, right? So you can apply law of conservation of linear momentum in this system. Is that right? So this system has two things, right? The person and the snowball. Is that right? Right?
Yes.
Initially, the snowball is in the hand of the person, right? He has not thrown it. Is that right? Is that right? And in the final situation, he has thrown the snowball. Is that right?
Yes.
Is that right? So initially, the momentum of the system, what is that? Is that momentum of the man plus momentum of the snowball. Is that right?
Yes.
Is that right? Okay. So what is that? Let's see that. So initially the person is moving with 2.5 meters per second in the forward direction, and there is a snowball in his hand, right? Is there a snowball in his hand?
Yes.
Okay. So if that snowball is in his hand, right? So what is the mass of the person? That is 60 kg, right? 65 kg. So 65 kg multiplied by 2.5 meters per second. Is that right? And the snowball that is of mass of 0.045 kg. Is that right? Is that right? And that is also moving at 2.5 meters per second because that is on the hand of the person. Is that right?
Yes.
Is that right? So this is the initial momentum of the system. And what is the final momentum of the system? Now in the final system, what is happening is that now the man is moving with a that 65 kg man that is moving with a speed of what? What is the speed of the man? We don't know, right? Is that right?
Yeah.
We don't know what is the final speed of the man. That is v. Okay. Okay. And what is the speed of the snowball? What is the final speed of the snowball?
0.
Please read the question. Is that 0? Check that.
Wait, is it 0? Wait, hold on. No, wait, no.
So snowball forward.
It's 30.
With a
It's 30.
30, right? Yes. So it's 30, right? So now the final speed of the ball is 0.045 multiplied by 30. Is that right? Is that right? So when you consider the system as snowball and the man, right? So this is the final momentum of that system. Is that right? Now, since there is no external force acting on the system, so and this is an isolated system, right? So the momentum will be conserved. So the initial momentum will be equals to final momentum. Is that right? Is that
yes?
Right? We will equate both of them, both of this, and you will find the final velocity. Is that right? Of the man.
Yes.
Is that right?
Uh-huh.
What after that? So you will get the final velocity of the man, right? Now, how would you find what are the velocities of the two people after the snow is exchanged, right? Okay. Okay. Now the second person is at rest. Is that right? Is that right? He is on the skater board, right? So his initial momentum is, what is the initial momentum of the second person? Is that 0?
Yes.
Because this was at
wait,
rest.
no, wait. The first person. Oh, wait, no, he's at rest. Yeah.
Oh, wait a minute. So what you are considering as the system in the second case? Now in the second case, you are interacting the ball, the snowball, right? This is snowball and the man. Is that right? So would you consider both of them as the system?
Yes.
The snowball and the man. Because if you consider only the man as the system, then when he catches the ball, then the ball will exert force on it, right? And that will become external force, right? Is that right? So you have to consider the snowball and the second man as the system, right? The second man as the system, right? Is that right? So if you consider both of them as the system now, so what is the initial momentum of the system?
0.
Okay. So what does the system consist of? The snowball and the second man. Is that right? In the second case.
Yes.
Is that so? What is the momentum of the man? Initial momentum of the man?
Of the man is 0, right? Because he has 0 velocity. He's at rest.
Yes. And the moment and the system consists of snowball and man both, right? So what is the initial momentum of the man, of the snowball?
0.045 times 30.
So what is the initial momentum of the system? That is 0 plus 0.045 multiplied by 30. Is that right? So this is the initial momentum of the system. The initial momentum of the system is not 0, right? It is 30 multiplied by 0.045. Is that right? Is that right? Now, final momentum. Now, final momentum when the ball is being like the second person catches the ball, right? So when the second person catches the ball, now both of them will attain a same velocity, right? Because he has catched this ball and the ball is now in his hand, right? Okay. The ball is now in his hand, right? So now both of them will move with the same velocity in this direction, right? We don't know the direction, that's it. Okay. So now the both of them will move up with the same velocity. Now, what is the final momentum of the system? So mass of the snow multiplied by velocity of the snow plus mass of the second man multiplied by velocity of the second man. And will the velocity of the second man and the velocity of the ball be same in the final case? Right. So this can be written as ms plus m2 multiplied by v. Is that right? And what is the mass of the second person? That is 60 kg, right? So 0.045 plus 60 kg multiplied by v. So this is the final momentum of that system, right? And you will equate this final momentum to the initial momentum you got here. Is that right? And by this,
Yes.
you will get the final velocity of the second person. Is that correct? So you have
Yes.
seen, we have selected two systems. In the first system, we have considered the first person and the snowball. And in the second scenario, we have considered the second system as the snowball and the second person. Is that right?
Yes.
Is that right? Why we have considered the snowball and person as the systems in both the scenarios? Because if we consider that, then the force by the ball on the man and by the man on the ball becomes internal forces, right? Right. So no
Mm-hmm.
external force is active there, right? And you can apply law of conservation of linear moment. Is that right? Is that making
Yes.
sense? Okay.
Yes.
So that's all. So you can solve more questions on this. Is the concepts clear for now?
Yes.
Okay. So try to solve more questions on this. Okay. Momentum conservation is a very good concept. Okay. There are some, they have some missing graphical questions. Oh, they have some graphical questions. Okay. So in today's class, we have given a lot of time to the theory. Okay. In next class, what we'll do, we'll practice more questions. Okay.
Okay.
Okay. Okay. Perfect. Okay, then bye
All
bye.
right.
And one more thing. Okay, the thing is that don't like I will recommend you what to do. Like if you are doing the classes, right? So if you have taken one class now, right? So try to take the class, another class on the next day or day after. Okay, because if you give a lot of gap between the classes, right? Then you will forget the things which I am teaching in the class. Are you getting that? Are you
Yes.
getting? That's why don't create a big gap between the classes. Okay.
Okay. Okay.
Okay then. Bye bye. Take care.
All right. Thank you. Thank you. Bye bye.
Yeah, welcome.